In this question number 24, we need to find the equivalent resistance. In each of the resistances shown in the figure has a value of 20 ohm, 20 ohm, 20 ohm and 20 ohm. Then find the equivalent resistance between points A and B. That is first part. So let us do the first part and then we move on to the second part, which says that so I would suggest that if you have not taken my course in Wheatstone Bridge, you must see that, because I have very clearly explained something in that circuit which very well relates to this problem. So basically what is happening is we have a resistor here and then another resistor here, resistor here, and we need to focus on these 2 points. These are points A and point B. And these resistors are all equal, and this is very important. There is a reason why they have seen here and why these resistances are equal. Let us say mentally connect a voltage source between point A and B, something like this. Then, and for now I have just not placed this diode. Just mentally forget about this diode and analyze the circuit without the diode in place. So a current starts flowing like this, and it has 2 paths from here. One, it can go through this path or it can follow this path, and both these paths have a resistor divider and they have the same ratio, 1:1. That means that between A point and B point, the voltage will get divided between this resistor and this resistor. In the same way, the voltage gets divided this resistor and this resistor. Because these resistors are same, the ratio of this voltage and this voltage will be same. In particular, half voltage will appear here and other half will appear here. What it means is, and the same thing for here, that means if I call it point X and then point Y, then because of this symmetry, the voltage at point X is the same as voltage on Y. That known, now let us place the diode. On the 2 ends of the diode, they have the same voltage. That means the diode is not forward bias. When there is not forward bias, there is no current in the diode. When there is no current in this diode, we can just simply remove this diode from the picture as far as the calculation of the equivalent resistance is concerned. And this is because the equivalent resistance between A and B is nothing but R is equal to this voltage V. If we have a voltage V here, V divided by the current flowing through this circuit. And because the current flows through it, but there is no current flowing in this resistance, it does not change whether the diode is there or not. So this circuit is equivalent to with diode and without diode, does not matter as far as the equivalent resistance is concerned. Now we can put these two in series. The 20 ohm plus 20 ohm is 40 ohm. So this circuit becomes same as this circuit, and the 40 ohm and 40 ohm are in parallel. So the equivalent resistance will be 40 divided by 2 or 20 ohm. So that solves this problem. The second part of the questions asks, what does it depend on whether the point A or B is at higher potential? So we have 2 cases. Number 1, A is at higher potential and B is at lower potential. In that case, if we go through this potential will be X will be higher and this will be lower potential. And the same case, Y will be at higher potential and this will be lower potential, but X and Y will still be the same at same potential. In the same way, if we reverse the battery direction like this, then the current starts flowing like this. But in that case as well, point X and point Y are at the same potential. So whether or not A is at higher potential or B is higher potential, these things does not matter. We will still have equivalent resistance as 20 ohm.